Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So, I will continue my video session for Cambridge IGCSE, that is 0620 past paper. And this time I have selected October November 2023. The paper is 42. The total time is 1 hour 15 minutes. It's paper 4 theory extended version. You have to answer all the questions. You may use calculator in this paper. The total mark for this paper is 80. So let's start the paper. Here's question number 1. Table 1.1 gives the electronic configurations of some atoms and ions A to G. Now A till G, these are the electronic configuration of atoms as well as some ions. Answer the following questions about A to G. Each letter may be used once, more than once, or not at all. So it's part A noble gas atom. Group 8 elements are noble gas. We have helium, neon, argon, krypton, xenon, radon, and organon. What's so special about group 8 is that except helium, they all have 8 valence electrons. So straight away, what you will do, you will look at the 8 valence electrons. Helium is at top. So proton number of helium is 2, which means the electronic configuration is 2. We can't find helium here, but you can find other inert gas. Like I can see the configuration of neon. It must be B. You see the configuration of B, it's of neon. So you'll write B for part A. Part B, an atom of an element in group 6. So group 6 elements, they have 6 valence electrons. 6 valence electrons. So electronic configuration in which you can see 6 valence electron will be the answer for this part. And you can see it must be F, 286. That's the configuration given. C, an atom with an atomic number of 14. Atomic number of 14 means it must have 14 electrons. 14 electrons. So you have to count the total number of electrons in this case. So if you count the electrons in A, it will be 5 plus 2, 7. What about B? It's 2 plus 8, 10. C, 2 plus 8 plus 2, 12. D, 2 plus 8, 10, 10 plus 4, 14. So D must be the right answer for this part. D, atoms from the same group. Now for the atoms from the same group, they must have same valence electrons. Same valence electrons. So straight away look at the valence electrons of all of these atoms or ions. You'll see A and E, they are having same valence electrons. These are the valence electrons. Both of these are having 5 valence electrons. So I will write A and G for this part. A and E. E, a halogen atom. A halogen atom, it's a group 7 elements. Group 7 is known as halogen. they must have 7 valence electrons. 7 valence electrons. So if you look at the atoms and ions, so it must be G. For this one, it must be G, as this is the one which is having 7 valence electrons. So I will write G here. F. An atom of an element which is a good conductor of electricity. So it must be a metal. So metals, we have 3 groups, group 1, 2, 3. These are of metals and they have 1, 2 and 3 valence electrons. So if you look at the table, you have to look for the 1, 2 or 3 as the valence electrons, and I will find C is the one which is having 2 valence electrons. So C must be the right answer in this case. It's a metal, it must be a good conductor of electricity. So I write C here. G, a stable ion of group 5 element. Group 5 element, they have 5 valence electrons. So if you form a stable ion of this group, it must be gaining 3 more electrons. So plus 3 gives 8 valence electrons for the ions. So it must be the element having full configuration. So in this case, it must be B because the configuration is complete. So it must be the ion, stable ion of a group 5 element. H, an atom that forms an ion with a 2 minus charge. An atom that forms an ion with a 2 minus charge. So if you look at the periodic table, it's group 6. They form the ion with -2 charge, like oxygen -2, sulfur -2, and so on. Which means that it must be needing 2 electrons to complete its valence shell and must have 6 valence electrons. So look for the atom in the table having 6 valence electrons. So it must be F. The configuration is clear, 286, which indicates having 6 valence electrons. So of F must be the right answer in this case. Moving to next question. Question number 2, cobalt and copper are transition elements. A, copper has 2 naturally occurring isotopes, Cu63 and Cu65. Cobalt has only 1 naturally occurring isotope, Co59. 1. Complete table 2.1 to show the number of protons, neutrons, and electrons in the Co59 atom and the Cu2 plus 65 ion. For both of these elements, I need to look at their proton number in order to find the number of protons as well as electrons. So where is cobalt? Here is cobalt. The proton number is 27. Copper. Here is copper. The proton number is 29. So 27, 29. These are the proton or atomic numbers. Proton or atomic numbers. So for cobalt, the number of protons must be 27. In order to calculate the neutrons, I need to subtract 27 from 59. -59 minus 27, 32. What about electrons? It's a neutral atom, so electrons must be equal to the number of protons, which means 27 will be the answer in this case. What about Cu2 plus ion? The number of protons, you see the proton number, it's 29, which means the number of protons is 29. Number of neutrons, you have to subtract 29 from 65. 65 minus 29, 36. Now electrons. If you see the charge is 2 plus, it means it has lost 2 electrons. So simply subtract 2 from 29, you will get 27. So 27 will be the answer. Table 2.2 shows the relative abundance of the two naturally occurring isotopes of copper. Isotopes Cu63, Cu65. Relative abundance is 70% and 30%. Calculate the relative atomic mass of copper to 1 decimal place. You simply have to multiply the nucleon number of these isotopes with their relative abundance, which is provided in percentage. So 63 multiplied by 70 and divided by 100 plus 65 multiplied by 30 and divided by 100. Taking 100 common here. 63 multiplied by 70, 4,410 plus 1,950. Adding up these, $63.6. This will be the final answer for this question. B. One physical property of transition elements such as copper and cobalt is that they are hard. Other metals such as lithium are softer. State two other physical properties of copper and cobalt which are significantly different from lithium. So lithium is a group 1 metal. Here is lithium. So they must be softer, which is already provided, low density, low melting point. And cobalt and copper, they are transition elements, they have high melting point and high density. So I will write high density. And high melting points. Part C, both copper and cobalt can form colored compounds. Some of these compounds contain water of crystallization. Define the term water of crystallization. Now, water of crystallization, they have water as part of the salt. So you have water molecules in hydrated crystals. So you write water molecules in hydrated crystals. Number two, state the color and formula of hydrated cobalt 2 chloride crystals. So it's pink or red. Pink or red. Now formula, they have mentioned the oxidation number of cobalt, which is +2 here. Cobalt +2. And chlorine, it's in group 7. Here is chlorine. Valency is -1. So I will write -1, ignore the charges. These subscripts will be exchanged. So you will get, sorry, so CO is the symbol for cobalt, not Cu. COCl2. COCl2. Now they are saying hydrated. The hydrated one, the formula is 6H2O. 6 molecules of water molecule are part of this cobalt 2 chloride crystals. Moving to next question, state the color change seen when a few drops of water are added to anhydrous copper 2 sulfate. Anhydrous copper 2 sulfate is white in color and it will turn to blue when water is added. So I will write white to blue. 4. State how this color change can be reversed. You simply have to heat the hydrated copper 2 sulfate. Moving to next question. Number 3, iron is manufactured in a blast furnace. A. 3 of the starting materials added to the blast furnace are coke, iron ore, and limestone. Name the other starting material added to the blast furnace. It must be hot air because initially the coke is reacted with hot air to get carbon dioxide. Hot air. And the reaction that's taking place in the blast furnace, they all are at high temperatures, so hot air must be there. B. The source of iron in the blast furnace is Fe2O3. Fe2O3 is found in iron ore. Number 1, name the main ore of iron which contains Fe2O3. The name is hematite. It's something which you have to learn by heart. Number 2, the iron in Fe2O3 is reduced by reaction with carbon monoxide. The unbalanced symbol equation is shown. Complete the equation. So we have Fe2O3 plus dash CO gives CO2 plus Fe. So if you will balance the equation, on the right hand side, I will put 2 in order to balance iron. Now what about oxygen? If I will place 3 before CO2, oxygen, oxygen is balanced. No, oxygen is not balanced. We have 4 on the left hand side. The carbon is also not balanced. So if I will write 3 before CO, now the whole equation is balanced now. Fe2O3 plus 3CO gives 3CO2 plus 2Fe. Number 3, state the color change in oxidation number of iron in the reaction in 2. So the change in oxidation of iron in Fe2O3, it's iron 3 oxide. The oxidation number is +3. So I will write +3. And when it's reduced, the oxidation number becomes 0. So it's changing to 0, +3 to 0. Number 4, explain how the change of oxidation number shows that iron has been reduced. This decrease in oxidation number If there's increase in oxidation number, we call it oxidation, but in case of reduction, there must be decrease in oxidation number. So I will write decrease in oxidation number. C. The major impurity in iron ore is silicon 4 oxide. Limestone is added to the blast furnace to remove this impurity. Write two symbol equations to show how silicon 4 oxide is removed. For each question, state the type of chemical reaction that takes place. So in order to remove silicon 4 oxide, which is the impurity, you need to react with basic oxide. So acetic oxide, so you have to react with basic oxide. And here we have added limestone. So limestone is producing basic oxide, which is calcium oxide. So the equation must be CaCO3 gives CaO, which is calcium oxide, plus CO2. This is decomposition reaction. It's actually thermal decomposition because taking at high temperature. Thermal decomposition. Now equation 2, it must be the reaction between silicon 4 oxide SiO2 and calcium oxide CaO. The product is CaSiO3 and it's an acid-base reaction. Because in this reaction you are reacting acetic oxide with basic oxides. Part D. Iron is converted to steel by mixing it with carbon and other elements. Number 1, state the term given to a substance which is a mixture of metal and other elements. So it's an alloy. Alloy are the mixture of metals with other metal or non-metals. Number 2, name one element other than carbon mixed with iron in the making of stainless steel. So in the stainless steel, in order to avoid or prevent corrosion, nickel or chromium is added. So you can either write nickel or chromium. Part E. Preventing the rusting of steel is important. State the chemical name of rust. It's hydrated iron 3 oxide. Rust is hydrated iron 3 oxide. F. Steel can be coated with zinc to prevent rusting. This provides both a barrier method and sacrificial protection. Number 1, state the term used for coating steel with zinc. Now, there's a special term used when you're coating something with zinc. You call it galvanizing. So I will write galvanizing. Part 3. Describe another barrier method for preventing rusting. You can put grease, paint it, or coat it with plastic. So I will write greasing or oiling, painting, or coat it with plastic. These all prevents rusting. So any one from these, any one from. Explain how zinc provides sacrificial protection. So it reacts in preference to iron. So you write zinc with the concept behind it, that is zinc being more reactive than iron. So you write zinc more reactive than iron. So this must be the common statement. And the other statement, zinc reacts, corrodes, or oxidizes in preference to iron. Anyone from these? Anyone from zinc reacts or corrodes? Zinc reacts, corrodes, oxidizes in preference to iron. So anyone from these? Moving to next question, which is question number 4. This question is about lead 2 chloride PbCl2. A student prepares a sample of insoluble lead 2 chloride PbCl2 by mixing aqueous solutions of two salts in a beaker. Part 1. Identify two soluble salts suitable for making lead 2 chloride when mixed together. Now let's take the soluble salt of lead. So we have all nitrates are soluble, so I can take lead nitrate. And any other more soluble salt of more reactive metal than this lead. Any other salt of metal more reactive than lead. So it can be, we are making chloride, so you can take sodium chloride, sodium or calcium chloride. Number 2, write the ionic equation for the formation of lead 2 chloride by mixing aqueous solutions, include state symbols. So in the ionic equation, omit the ions of that are common on both sides of the equation. So we have ions of other salt that will be common in this equation. For example, nitrate must be common. Must be common on both sides of the equation, so it will be omitted. Lead is forming insoluble salt, which is PbCl2. So Pb must be there on the product side, PbCl2. It's in the solid state. And on the reactant side, you have Pb plus 2 aqueous plus 2Cl. I balance the equation, 2Cl minus aqueous. Now this will be the final ionic equation in this case. List the steps students should take in preparing a pure sample of lead 2 chloride from the mixture in the beaker. Now the student have to filter it and wash the residue with deionized or distilled water, then dry the residue in warm place. So you write filter the mixture to obtain lead 2 chloride noise residue. The next step, wash the residue. Wash the residue with distilled water, distilled or deionized water. Then dry the residue. Dry the residue. Moving to next question, which is question number B. The student carries out an electrolysis experiment on molten lead-2 chloride using the apparatus shown in figure 4.1. Chlorine gas forms at the anode and escapes from the apparatus. So here's the apparatus. We have molten lead-2 chloride. Number one, explain why lead-2 chloride needs to be molten before it will conduct electricity. Now, in the molten state, the ions are free. So you have mobile or free ions. Mobile or free ions. Part 2. Write the ionic half equation for the reaction occurring at the anode. Now, at the anode, you have chloride ions losing electrons. So it must be Cl minus giving. So chlorine, it's a halogen, halide ion. So it produces halogen, Cl2, and releasing one electron. So in order to balance this equation, I have to put 2 before Cl negative and 2 before the electrons. Number 3, state the test for chlorine gas. So the test must be damp litmus paper. So the damp litmus paper gets bleached. So you write observation bleached. Number 4, describe what is observed at the cathode. Now at the cathode, we are getting lead metal. You will get shiny gray solid. Shiny gray solid at cathode. Moving to question number 5. Chemical reactions can involve transfer of thermal energy. A. State the term used for the transfer of thermal energy during the reaction. You call it enthalpy change of reaction. It's known as enthalpy change of reaction. Part B, tetrachloromethane gas CCl4G reacts with steam as shown. And this reaction is reversible. The forward reaction is exothermic also. So I will write the sign for delta H in the forward direction. It must be minus. So in the backward direction, it must be endothermic plus. Number 1, state what happens, if anything, to the rate of the forward reaction if the concentration of CCl4 is increased. Explain your answer in terms of collision theory. Now you are increasing the concentration of CCl4, definitely the rate of reaction increases. So this will be the first statement. Rate of reaction increases. Now you have to explain it in terms of collision theory. So you will having more CCl4 particles per unit volumes. More CCl4 particles per unit volume. Due to this, you have higher frequency of collision between the particles. Frequency of collisions increases. And we have two reactants, CCl4 and H2O. So we'll write between CCl4 and H2O particles. Number 2, state what happens to the position of equilibrium, if anything, when the pressure is increased. Explain your answer. Now they are asking to the position of equilibrium. So let's count the number of moles of gases. First of all, for gases, we have all gases here, both on the reactant side and the product side. So on the reactant side, 1 plus 2, there are 3. And on the product side, there is 1 plus 4, 5. So for your convenience, I am writing it here. 3 moles of gases, 5 moles of gases. So remember, when you increase the pressure, the equilibrium will shift to the side with less number of moles, or you can even quote it volume of gases. So you write position of equilibrium moves to the reactant side. Position of equilibrium moves to the reactant side. Now you can quote the number of moles either on the product side or on the reactant side. Refer number of moles or volume of gases either reactant or product side. So if you write for the reactant side, you have less number of moles, and for the product, you will write more moles. More moles. Here you have less moles. Reactant side, product side. Moving to next question. That's question number 5. Part 3 of this question. Figure 5.1 shows an incomplete reaction pathway diagram for the forward reaction. But the reaction is same. On figure 5.1, insert the formula of the reactants and products. Draw an arrow labeled EA to show the activation energy. Draw an arrow labeled delta H to show the transfer of energy in the reaction. So for the reactant, is the exothermic reaction. Reactant must be on the high energy state, and it's on the left hand side. So you will have CCl4 G plus 2H2O G, and the product which will be on the lower energy state, CO2 gas plus 4HCl gas. EA, this must be EA. So label it EA, and the energy difference between reactant and product, which is delta H. So I will write delta H. They are not asking you to show the signs. So this will be the complete answer. Number 4, define the term activation energy. Minimum energy the colliding particles must have to react. It's the minimum energy. The colliding particles must have to react. Number 5, state one way in which the activation energy of reaction can be changed. You can decrease the activation energy by adding catalyst. Decreased by adding catalyst. Moving to question number 6, part 6 of this question. The equation for the reaction between tetrachloromethane gas and steam can be represented as shown in figure 5.2. Here's the reaction. Table 5.1 shows some bond energies. Use the bond energies in table 5.1 and the delta H value for the reaction to calculate the HCl bond energy using the following steps. Now calculate the energy needed to break the pores in the reactant side. So here we have 4 CCl bonds, 1, 2, 3, 4. So I will multiply 4 by 340 plus we have 1, 2, 3, 4. 4 bonds of HO. So I will again multiply 4 by 460. So what we will get? 4 multiplied by 340 1360. 1360 plus 1360 plus 4 multiplied by 460, 1840. 1840. Adding up these values, 1360 plus 1840, 3200. 3200 kilojoule for the reactant side. Calculate the energy released when the bonds in carbon dioxide form. So carbon dioxide, 2 bonds of carbon dioxide. So we'll multiply 2 by 805. 2 multiplied by 805. 1610. 1610. Calculate the HCl bond energy. The formula. What is the formula? Energy involved in breaking bond minus energy released in bond making equal to enthalpy change. So we have 3200 minus 1610 plus we have 1, 2, 3, 4. 4 HCl bonds. So I will write 4x. I will take 4x here. And enthalpy change is given, which is minus 130. Minus 130. So the equation becomes 3200 minus 1610, 1590 minus 4x is equal to minus 130, or 4x minus 4x is equal to minus 130 plus 1590. minus 130. The answer is 1720. 1720 minus 4x equal to 1720. So or x is equal to minus x equal to 1720 divided by 4. One seven two zero divided by 4. 430. 430 plus 430 will be the final answer in this case. Moving to next question. Question number 6. The last question. A homologous series is a family of organic compounds whose members have similar chemical properties. A. Give 2 characteristics that are the same for all members of a homologous series. So you can write any one of these, any 2. They follow same general formula, follow same journal formula, contain same functional group. They have same chemical properties. Or they have same methods of preparation. Same. Part B, in terms of structure, state how one member of a homologous series differs from the next member of that homologous series. It's CH2 unit. They all differ by CH2 unit, each member. In fact, each member differs by CH2 unit. C, A, B, and C are organic compounds. A has a molecular formula C12H24. B has the name tetradecane. C has 3 carbon atoms and is in the homologous series with the general formula CnH2n plus 1 COOH. Name the homologous series each organic compound belongs to. Now, if you look at the formula number 1, it's following CnH2n plus 2. If you place 12 here, C12, you will get 2 multiplied by 12, 24. 24, sorry, it's following CnH2n, not CnH2n plus 2, CnH2n only. 2 multiplied by 12 is 24. So which means it's an alkene. It must be alkene. So you write alkene here, alkenes. Now the same part B, for B, the name is tetradecane, name ending on ane, which means it belongs to alkenes. And the last one, it's following the general formula of carboxylic acid. So I will write carboxylic acid for C. Number 3, name C and draw the displaced formula. Now there are 3 carbon atoms in C. So I will predict the formula first. C3. 2 multiplied by 3 is 6. 6 plus 1 is 7. H7. And COOH. There are 4 carbon atoms. So you write butanoic acid. Sorry, they are saying total 3 carbon atoms. So I must have to place 2, not 3. So C2H, 2 multiplied by 2 is 4. 4 plus 1, 5. 5 COOH. And it's a propanoic acid. So it must be propanoic acid. Displayed formula of propanoic acid, there must be COOH here. 1 COOH. And there are 2 carbon atoms, 1, 2, showing the bond between carbon and hydrogen. So this will be the final displayed formula of propanoic acid. The amino acids are a homologous series where each member has a general structure shown in figure 6.1. The R side chain contains carbon. An amino acid has a relative molecular mass of 103. Reduce the formula of the R side chain in this amino acid. Show your working. So first of all, I'm going to write down the molecular formula of this. We have 1 N here, so I will write N. 2 carbon there, so I will write C2. Oxygen 2, O2, hydrogen 1, 2, 3, H3. And then we have 4 hydrogen atoms. And we have R. For R, I am taking X. And COH. Where is N? N. The nucleon number is 14, oxygen 16, carbon it's 12. So we have 1 N. So I will write 14 plus 2 carbon. So 2 will be multiplied by 12 plus 2 oxygen, 2 will be multiplied by 16 plus 4 hydrogen. So 1 multiplied by 4, you will get 4 plus X for R. So 14 plus 2 multiplied by 12 is 24 plus 2 multiplied by 16 is 32 plus 4 plus X is equal to 103, which is the relative molecular mass. So 14 plus 24 plus 32 plus 4 minus 103. 29. X is equal to 29. 29. Now for the R is the alkyl group. It's the alkyl group. So we have alkyl groups CH3. The formula for alkyl group is CnH2n plus 1. If n is 1, the formula must be CH3. If n is 2, it must be C2H5. So calculate the relative mass of these. For CH3, we have 12 plus 3 gives 15. In case of second, C2H5, we have 2 multiplied by 12, 24. 24 plus 5 gives 25, 29. So it must be C2H5. State the name given to the natural polyamides formed from amino acid monomers. It's protein. So you write proteins. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.